Greetings from Montalcino, from the land of Brunello di Montalcino. We are in southern Tuscany, in the province of Siena, and we are just underneath the Amiata mountain, the highest mountain in Tuscany. The weather in this part of Montalcino is very much affected by this mountain because the weather fronts come from the coast and drop the rain on the mountain. And this part of Montalcino is spared the rain on most occasions. So we are very concerned about the climatic change and the droughts that we are seeing ever so often in this part of Montalcino. In fact, we are in a drought situation just now, and we had a severe drought in 2012 and 2017. As you can see from the vineyard behind me, there is no irrigation installed in this vineyard. In fact, until not so many years ago, we were not allowed to irrigate our vineyards. I want to share with you a very exciting research project we conducted in this vineyard, and I will use a university thesis written by a student of agronomy, of viticulture of the University of Florence, to give you all interesting details of how this zeolite, how this volcanic rock can affect the behavior of the soil and the water retention of the soil. So I have put together a presentation, the slides that I'll show you now, to give you all the details of this interesting research project. It is called Life Zeowine. It's a demonstration project that aims to improve the protection and management of the soil, the well-being of the vine, and the quality of grapes and wine through the application to the soil of an innovative Zeowine product. So I'm going to use the material put together at the University of Florence in the course of viticulture under the direction of Professor Giovan Battista Matti. The work was executed by a student called Maddalena Fucile in the year 2020. The information I'm going to show you was put together through field and laboratory analysis aimed at investigating the effectiveness of Zeowine in terms of improving the physiological activity of plants, net photosynthesis, stomatal conductance, transpiration and water use efficiency, and the quality of the produced grapes, sugar concentration at harvest time, total and extractable anthocyanins and polyphenols. The analyses that were carried out allow us to state that the application to the soil of the Zeowine is effective in improving the grapes and consequently the quality in the production area of Brunello di Montalcino. Moreover, this practice was found to be sustainable as it allows to recycle the byproducts of the supply chain. So the study was performed on one of the vineyards of Coldorcia in Montalcino, one of the Brunello vineyards, called Nastagio Carrata. It is a vineyard, well, the whole estate is certified organic. I gave you here the latitude and longitude, so 43 degrees north, best area for grape production in the world. The vineyard I planted in the year 2006. The variety is Sangiovese, and in fact it's a clonal selection. It's clone number 7 from the Chianti 2000 clonal selection. The rootstock is 420A, which we use extensively on the estate. The density of planting is 6,000 plants per hectare, so reasonably high density. And here you have a picture of the vineyard. So the other details of the vineyard, Nastagio Carrata, is that the fertilization takes place through the use of green manure and compost. The soil composition is, as you can see, almost half of it sandy. The pH is a quite alkaline soil, 8.3. Very low organic material, below 2%. 25% of limestone, and that goes hand in hand with the alkaline condition of the soil, and also a very low nitrogen content in the soil. The study was divided in two treatments, one entitled compost and the other one entitled Zeowine. The distribution of compost and the Zeowine took place on May 19, 2020. And as an additional piece of information, the two treatments were distributed according to a randomized block scheme, as it's customary in research projects. So the Zeowine composition that we used is compost on one hand, manure that comes from the mountain, the Agnata mountain, from an organic farm. Straw, we have a lot of cereals produced on the estate, so we have a fair amount of straw that we use always in our compost. The prunings from the vineyard and from the olive trees as well, stalks and other byproducts from the vinification. And for Zeowine, we added to the same compost, we added 10% of zeolite in a granular form. The total compost that was distributed per hectare, equivalent 20 tons. So the cost of applying this 10% of zeolite to a hectare is in fact 1,000 euros. So we're talking about 2 tons of zeolite, considering the 20 tons per hectare and the 10% factor. The zeolite, just to be more precise about the origin of this mineral rock, it's aluminosilicate of volcanic origin. So we are using a natural zeolite. There are synthetic zeolites as well, but we decided to use a natural one. It's 90% pure, and it was extracted in a mine in Slovakia, in the Republic of Slovakia. So here you can see the same compost with the zeolite. The white stuff that you see on top of the compost just before mixing is in fact the granular zeolite in a proportion of 10%. The details of the 2020 growing season, in which the test and the readings took place. Here you have the monthly average temperatures. We had a fairly good season in terms of climate. We did not have the very severe heat waves that are one of the features of the climatic changes in recent years. So a moderate heat compared with some excesses we've seen in recent years. In terms of rainfall, it was a good year. We had rainfall, as you can see here on the chart, and at harvest time as well. So it was representative of a year that may have an average of about 700 millimeters of rain in the 12 months. So let's get to the readings that were conducted by the student of the University of Florence in the two samples, the one Zeowine, the other one compost. And in terms of leaf surface, this is leaf surface taken at harvest time. So at the end of August, beginning of September. And as you can see here, there is a visible difference in terms of the leaf surface, that growth of leaf surface of the Zeowine sample as opposed to compost. Now I'm going to show you some charts of different readings. As I remind you that the red line is the one just compost by itself, and the yellow line is the compost plus zeolite, in other words, the Zeowine. The readings that have the black asterisks at the bottom are readings that where the difference between the two lines is sufficient to be significant. So here we have a water use efficiency reading in July and in August, all the way up to the harvest. And as you can see, towards the end of the season, the water use efficiency reduces the gap between the two samples. But all through July and August, we have a good difference, an interesting difference between the two readings. Then we have the transpiration rate of the two samples, and here again we have a smaller difference than the reading before, but interesting, in my view, the fact that there is a difference altogether. The net photosynthesis of the two readings, and here an interesting gap visible and sizable. Midday water potential. Here again, the Zeowine has a higher water potential, as you can see on the chart. And then we come to the sugar content of the samples all the way into the harvest. So in the 2 weeks preceding the harvest, we had not huge difference in terms of sugar content, but all the same a reading with sufficient difference between the two samples to be significant and to warrant the black asterisk, as you can see. The berry weight here we have going into the harvest a increasing difference between the compost reading, the red line, and the Zeowine yellow line weight of each berry of the grapes. Total anthocyans. This is also, I believe, a very interesting reading. And extractable anthocyanins. It's interesting how through the last part of the summer there's not that much difference, but as we get to full ripeness, the gap starts widening. There's no black asterisk here, but it would have been interesting to see it a little bit longer over time. Polyphenols, not much difference here except around 26th of August. But some more difference in the extractable polyphenols, as you can see here. I think the results are really very interesting. We can reach as a conclusion that the synergy of zeolite and compost is a better choice than compared with just compost by itself. It does increase the water retention capacity. It is actually estimated in 8 cubic meter per hectare in the doses of 10% of zeolite as we applied with the compost in this vineyard. It's also considered to increase the enzymatic activity related to the nutrient cycle, the absorption by the plant of the nutrients in the soil, as well as improving the soil structure of the organic material structure. The higher stability in yields of the vineyard over time is also hopefully a advantage that we may witness. And all in all, an increased sustainability of the wine supply chain thanks to the use of waste from the winter pruning and from other activities in the vineyard. So a very interesting project as far as I'm concerned. I'm going to expand it here in my vineyard. I'm going to increase the surface that in which I'm going to apply zeolite, and I'm going to continue researching and seeking results of the difference between the area treated with zeolite as opposed to the one that I have not treated. More results to come in the future. You are invited to come and visit. You're invited to come and share your experiences, and I'm very happy to share the ones we conduct here at Coldorcia, not only with zeolite, with other projects, other research projects over time. So hope to see you here in Montalcino, hope to see you here in Coldorcia. Bye-bye now. Bye.